Hi Intermediate, back with 4.7. This is video 6. Let's see if we can actually finish this one in one video. This is the third example I'm giving you. And even though it's a different function, a lot of the concepts transfer over. So we can sort of maybe move through this one a little quicker. So the tangent function, as you know, it's a bunch of repeats of this cubic looking shape. And you can see that it would pass the vertical line test, but it fails the horizontal line test. Because remember, there's an infinite amount of these, right? It just goes on and on and on with this pattern. Right? So it's going to fail the horizontal line test. So we're going to restrict it so that it's 1-to-1, so that the tangent function has an inverse. Because under a restriction, we can give it an inverse. So the universal cut for this one that we agree on all around the world is the center shape in between negative pi over 2 to pi over 2. Now notice on this one that I am excluding, right? I don't have square brackets, okay? I'm not putting square brackets on this. That would be wrong because I can't actually include negative pi over 2 to pi over 2 because there's asymptotes there. So this one has a modification that the other two functions we did don't have, where it has to be open on the ends of this domain. Okay, and the range for this one, it goes to positive infinity and negative infinity. All right, so that is the restriction, and under this restriction, this graph has an inverse. You probably know where I'm going next here. So now we're going to find the inverse. So we're going to go ahead and swap x and y. We're going to solve for y. The inverse function of tan is arctan. So arctan and tan undo each other. And remember that you can shorthand this, and this is actually said arctan. If somebody said it to you, they'd say arctan. Okay, so the domain and the range. So we have to swap the domain and the range from the original. So the domain becomes the range, and the range becomes the domain. So this function will output angles between negative pi over 2 and pi over 2, but not including those end values. So you got to be really careful when you do this one. So this one's very similar to the sine function. It's going to rotate up into quadrant 1 or down into quadrant 4. But unlike the sine function, this actually cannot include the unit circle on the ends. It can include the unit circle at this point. The tangent's positive here, the tangent's negative here. Okay, so that's the idea. That's like the most important part of this lecture, are these restrictions. Now let's solve them like we did before. So the arctan of 1 means you're trying to find theta. So where does the tangent of theta equal to 1? You have to remember that you're not allowed in quadrant 1 and you're not allowed in quadrant 2. Since this is positive, you have to be in quadrant 1. This is a triangle and not a unit circle. The tangent is not 1 on the unit circle. The cosine is 1 and the sine can be 1, but the tangent can't be 1. Okay, so this means it's 1 over 1. So we've got the opposite over the adjacent. So again, it's positive cos you're in quadrant 1. The opposite is 1. The adjacent is 1, which means that the third side has to be, the hypotenuse has to be radical 2. So you guys know that this is your 45, 45, 90. So it's 45 degrees, or in radians, which I think is better, but you know, no worries when you're first learning something. So either give it to me in degrees or radians. Okay, next one. So I'll write this out in theta for you. So theta equals, if anybody wants it this way, tangent of theta equals to negative radical 3. Tangent, you're not allowed to use second or third since it's negative, right? Negative falls in the fourth. So we're going to go like this. This is over 1. So what do we got here? We got opposite, we got adjacent. Opposite is negative radical 3. And adjacent is 1. We don't have to say it's negative, but you know what I'm saying. It's some people do that. Opposite's radical 3, adjacent's 1, so this has to be a 2. All right, so that tells us what triangle this is. So if you're across from the radical 3, you're 60 degrees. So theta has to be 6. Oh, I almost said it wrong. Ooh, caught myself, thank goodness. If you say the answer is 60 degrees, that's wrong, right? Because if you tell somebody the answer is 60 degrees, they're going to go, oh, you're in quadrant 1? And no, you're going to say my answer's in quadrant 4. Then you have to rotate me to quadrant 4. But the problem with this, if you notice, your answer has to stay in between negative pi over 2 and pi over 2. So you can't rotate in standard position. You can't give an answer like somebody might try to say, oh, the answer is 300 degrees, right? You can't say 300 degrees. Oh, I'm trying to write this in degrees for you. So what I'm saying is you have to stay, what I'm trying to say is you have to stay in between negative 90 and 90. So if you say 300 degrees in standard position, like if you rotate this way and say, oh, it's 300 degrees, that's wrong because it's not. It can't be. You can't give anything, you can only go up to 90, not including 90. So what this means is that you actually have to rotate clockwise. You have to, so I'm trying to give you the arrow going this way. See, I have my arrow going this way. You actually have to rotate in a negative direction. So I'm going to rotate this way, and so the actual correct answer here is negative 60 degrees. That is correct because negative 60 does fall in between this restriction. That's really the trick. As soon as you can get that, you've got it. You have to just fall within the restriction. I'm just going to write it in radians also, but again, either is fine. Okay, I'm going to have to do one more after this because we have to talk about the calculator, but at least I will get through tangent on one go. Okay, so here's that tangent function we talked about. That's your guy right in the middle, right? I just pulled it out and put it here. So we've got VAs at negative pi over 2 and pi over 2 okay, so we've got VAs at negative pi over 2 and pi over 2. So kind of how you want to think about the table is at negative pi over 4, you have negative 1. You have 0, 0, and you have pi over 4, 1. Okay, so if this would be the table I would suggest, and you just know that you have VAs at the end. Okay, so this one I'm going to do it a separate graph and not on top of it because this one's more sophisticated than the other two. So because this one has vertical asymptotes, the inverse has horizontal asymptotes. So the inverse actually has a horizontal asymptote at y equals to pi over 2 and a horizontal asymptote at y equals to negative pi over 2. Okay, so the VAs become HAs. And then you can see how these points flip. The rest of the points will flip for you, so you'll be fine with the rest of them. I'm just going to use a shorthand here, the negative 1 arctan. Okay, so then I'm flipping the rest of these points. Let me just get my bearings here. So pi over 4 would be halfway. Pi over 4. And then that's about 3/4, so 1 has to be a little bit bigger than that. Okay, so this 1 is negative. Okay, I'm good to roll now. Okay, Oh, I need to write pi over 4 here with the wrong guy. Okay. So at -1, we're at negative pi over 4. At 0, we're at 0. And at 1, we're at pi over 4. So try to picture this. If you cut this guy down the center like we always do with the inverse, right, and you got to flip it, right, the inverses have to flip over this line, y equals x. So this little guy here is going to flip this way. And this part here is going to flip this way like this. See how it flips over? You see that? So this guy has to go like this. Right? Use the same logic here. This guy is going to flip over the line like this. This guy's going to flip over the line like this. Remember, you have to have that kind of symmetry. So this guy's going to go down like this. And that's what the arctan looks like. And if you have your arcs down, that's going to be pretty impressive, because these are, we're in pretty sophisticated territory here. Okay, gang, I still got to do the calculator. I made it, I know this video is long, but I made it. So just, let's do the calculator, and I'll just sort of do a little housekeeping at the end of that video. Okay, catch you. Bye-bye.